Right, in this video I will talk about one of my papers, and this is the title of that paper, The Orientals as Three Weak omega categories. So, well, the Orientals were defined as the three strict omega categories on the simplices, although I guess I didn't quite say what free means in that context, but well, if you're interested, you can read Street's paper. And anyway, so the Orientals were the three strict omega categories, but the title, well, claims that they are also the three weak omega categories, well, on the same generating data. And here is the main theorem. So this somehow says that the Orientals are three weak omega categories. Now, what does it say? Well, so firstly, by a weak omega category, I mean a weak completion set. So everything here is happening in the category of marked simplicial sets. And the statement is that, so here is a map in the category of marked simplicial sets. This is the representable simplicial set, the standard and simplex, but this is supposed to be a marked simplicial set, so this has the minimal marking, meaning that only the degenerate simplices are marked. And on this side is the completion nerve of the nth Oriental. And what is this map doing? Well, so this nerve functor was defined by mapping out of the Orientals. So if you take the nerve of the Oriental, the nth Oriental, then there is an n simplex in that simplicial set corresponding to the identity on the nth Oriental. So what this is doing is just picking out that n simplex. And well, the claim is that this map is in the closure of these maps under taking pushouts and compositions. Now these maps are, well, the ones that appeared in the definition of weak completion sets, or well, also in strict completion sets. So these Horn inclusions, they were, well, encoded in the compositions, and these dash into double dash maps, they encode the fact that the composite of a pair of marked simplices should be itself marked. So what happens when we close this set under taking pushouts on compositions? Well, so what this is doing is basically taking pushouts of these things freely as compositions to the composable pairs detected by this Horn. And taking pushouts of these things simply marks composites of marked things. Well, I mean, for example, okay, so being a weak completion set means having the right lifting property against these things, well, with non-strict inequalities, but anyway. And so that somehow, well, I mean, that encodes that you can compose things and also the marked things that close under composition. But this marked simplicial set delta n, that doesn't have all the composites that you want. So you can somehow detect composable pairs in here by maps out of a Horn into your marked simplicial set, taking the pushout then somehow, freely adds the composition to that composable pair that you found. So that's the kind of thing that I meant. Anyway, so in that sense, this map here can be obtained by freely adding these compositions and also by marking composites of marked things. And well, so this ON is a strict omega category. So taking its nerve gives you, well, a strict completion set. And in the previous video, or maybe in the one before that, I said any strict completion set is also a weak completion set. So somehow by adding these compositions and marking composites of marked things, you can complete this delta n into a weak completion set. And well, if you know about model categories, which, well, I plan to make videos about in the future, but I haven't done that yet. Anyway, if you know about model categories, then here is more model categorical formulation of this result. So there's a model structure due to domain variety on the category of marked simplicial sets whose fibrant objects are precisely the weak completion sets. So that's what I mean by various completion model structure. And well, so this nerve of the nth Oriental is a weak completion set, so it's a fibrant object, and these maps are trivial cofibrations in the model structure. So, well, so is this map being a composite of pushouts of these things. So, well, so we have an object, a trivial cofibration, into a fibrant object. So this nerve of the nth Oriental is a fibrant replacement of delta n. Now, so that's the result, but now how did I prove it? Well, by combinatorics. But I mean, so the domain here is a very simple simplicial set. It's just a representable one. But what is this codomain object? Well, so this thing consists of strict omega functors out of Orientals of various dimension into the nth Oriental. So we are just looking at omega functors between the Orientals. Now, I guess I didn't say in the first video where I introduced the Orientals exactly like what general cells in this Oriental ON look like. I guess I sort of just mentioned the generating data and not the cells in the generated thing. But I mean, if you read Street's paper, I mean, there is an explicit description of what the cells in here look like. So I guess in principle, one can use that description to deal with these things, but that is, well, very complicated. So in the proof, I actually used an alternative description of, well, the strict omega functors between the Orientals, which is due to Richard Steiner, and that's what I will talk about in the next video.